On this video, we will be doing differentiation. This is just an introduction. Another video will follow where we'll be doing exercises. Maybe I will try to choose more difficult exercises, then we do them together. So in differentiation, let's say maybe we're given 3. 3 is a constant. So if we asked to find the derivative of 3, it is equal to 0. A derivative of a constant or of a number alone is equal to 0. But what if we've got a constant times a variable, let's say maybe 3x squared? Then everything changes if we want to find the derivative of this. The rule says if we are given a as a real number multiplied by a constant raised to an exponent, for us to get a derivative of this, we need to, the rule says we must take the exponent and multiply it to the real number that we have, which will give us a times n, and we must minus 1 to the exponent. So x comes back and this becomes n minus 1. So that is how we would sorry get a derivative of a constant times a function. Like on this case, we say 2 times 3, that is 6. So we minus 1 there. So we will have 6x. That's the derivative of 3x squared. Sometimes this will not be 3x. Sometimes it can be 3 sine x. It can be any function. We will also do the introduction of techniques that deals with trigonometry. So that was it on a constant and a constant times a function. Sometimes we will have sum and differences of functions. So if we have sums, I mean maybe we have 3, it won't be always x. Sometimes they can say 3y cubed plus 4y squared. So if they ask us to find the derivative of this, what we need to do is find the derivative of this alone and the derivative of that alone. So that is the derivatives of sums. So what would be the answer for us here? 3 times 3 is 9 y squared when we minus 1 there. 4 times 2 is 8. So it's gonna be 8y when we minus 1 there. So that is how we would do the derivatives of sums. Again, it won't be always be easy. Sometimes they can put trig here, sometimes they can put 2x plus ex. So, but as we are doing the introduction, we will continue and we will get there on how we derive how we get derivatives of such functions. So I just wanted to give you an introduction on how you would deal with finding the derivatives of sums. Sometimes we would be asked to find the derivatives of differences. By that I mean that or maybe we have 3x raised to 4 minus 2x raised to 2. So the same method that we applied here, we will apply it here and we will keep the sign. That is how we would find the derivative of this. So 4 times 6 is 12 x cubed minus 2 times 2 4x. So that's how we would find the derivatives of differences. So even though we were dealing with powers here, when we had 3x squared, and that rule applies to differentiation, where you are given a function that has a power. But sometimes we can be given this natural function ex. Um, let's just start with ex alone. So if we're asked to differentiate this function, we've got a rule that guides us, which says this is equal to ex. What if we're asked to find the derivative of 2 raised to x? Now we don't have e here, we've got a number. Again, here we also have a rule that guides us that we must now keep and always follow. It simply means that for us to differentiate this, we must let 2x equal to ln 2. That's the answer. So even if we were to ask to differentiate that, we would see that we have a plus sign. So that's gonna require us to use the derivative technique that we talked about when we were doing the sums. If it was negative, it was gonna be the derivative technique that we talked about when we were doing the differences. This and this, the derivative techniques for sums and differences is almost the same. You are just doing the same thing when you are deriving here. So this does not end here. Deriving can also go a little further. Okay, sometimes we can ask it to find derivatives of higher order, like if we were to refer to this as f at x, as f prime at x, if we were to refer to this answer as like that, we can also be asked to find a second derivative of this function, which means we'll be deriving this function again. They can also ask us to find a third, and so on. As long as we know how to derive, we can go as far as they want us to go. Sometimes in deriving functions, we will get some things like, let's say they say we must find the derivative of f at x, which is equal to x, and g at x, which is equal to x squared. What do I mean by this? By this I mean we are given two functions that we must derive. For example, let's say we are given x times x cubed, I mean x squared. Then they say we must find the derivative of this. Yes, someone might argue that why do we have to apply a product rule here? Well, I'm just using this an example to teach you the product rule. If you want to, you can make this equal to d, over dx x cubed, then derive that, you will get the same thing that we'll get when we use the product rule. Let's prove that. A derivative of x cubed, we know that it's 3x squared, right? So let's say we were to use a product rule, not this method. So a product rule says we need to take that function, which is f at x, and get a derivative of it, which is gonna be 1. And we need to get a derivative of that function, which is g at x. When you are given an expression, it will be given like this. It will be for you to locate which one will be f at x and which one will be g at x. F at x will always be the first one on your left, and the second one on your right will always be g at x. So g prime at x, we would say this is equal to, oh sorry, I made a mistake. Oh, let's put 3 there, because when we derived here we use x cubed. No, my mistake. It's x squared. So x squared is 2x. So now what does the product rule says to us? A product rule says if we want to get a derivative of f at x multiplied by g at x, we must let f at x multiplied by d over x g at x plus g at x d over y, d over x and f at x. So now let's substitute. This simply means here we will be getting the derivative of g at x, and here we will be getting the derivative of f at x. So what is f at x? It's x. What is the derivative of g at x? We said it's 2x plus, what is f at x? We said, what is g at x? Sorry, we said is x squared. And what is the derivative of f at x? We said is 1. So here x times x gives us 2x squared. X squared times 1 gives us x squared. So x squared plus x squared will add. So here we have 1. So 1 plus 2, it's gonna be 3x squared. This is the same as what we got when we did not apply this product rule. So even if you would just multiply, if you happen to get binomials, it's not always the case. Sometimes here they might say x sine x. So there is nothing we can do here. The only thing we can do is to apply this formula. So we must make this f at x and make this g at x, and then apply the formula. But if, let's say, maybe they say 2x squared plus 1 and 3x plus 2, we can FOIL this and use that technique we learned when we were doing a derivative techniques. sorry, a derivative techniques of sums. So we would get the same thing that a person will get when that person solves this using the product. So we said when we see positive, it's a derivative technique of sums. When we see negative, the derivative technique of differences. When we see the multiply, the multiplication sign, which is here but not written, we use the product rule. When we see divide, we use the quotient rule. So now let us discuss the quotient rule. So as I've said, when we see divide, we know it's the quotient rule. What does this rule say? Well, you will not see it divide, maybe like I've written it, but you might see something like x, let's say x squared plus 2x minus 1. Let's just say 2x squared here and say 2x cubed there. This it's product and sum alone, but once we put the division sign and we say x plus 5, then it becomes something else. Then now it requires us to do the quotient rule. If, let's say for argument's sake, this was 3x cubed divided by x, it would be better to divide and then find the derivative. But on this case, it's not possible. So now let us discuss what the quotient rule says. The quotient rule is almost like the same with the product rule. The only difference is that with quotient, here we will not add, we will minus, and we will also divide. So the quotient rule says if we given a function that we can say is f at x divided by g at x, for us to find the derivative of this, we need to take g at x and d over dx times f at x. Now we minus. We can put big brackets there. F at x d over dx. Now we'll be deriving g at x. We must divide by g at x and we must square that. So this formula helps us, like which function will make f at x here? It's gonna be this one, and this one would be g at x. It makes things easy. If you were to make this one g at x, by the way, you would get it wrong. So they always make the denominator simple than the numerator because we're gonna square that. So let's find f prime at x. It's gonna be 3x squared. This one it's gonna be plus 4x. And that one will go away because it's a constant. And g at x, g prime at x, sorry, it's gonna be 1. And 5 goes away because 5 is a constant. Now we need to substitute. For us to get the derivative of, let's write the expression as it was, x cubed plus 2x squared minus 1 divided by x plus 5. So the rule says we must take g at x. G at x is x plus 5. And we multiply this with the derivative of f at x. The derivative of f at x is 3x squared plus 4x. We minus by f at x, which is x cubed plus 2x squared minus 1. This must be multiplied by all of this, the derivative of g at x, which we said is 1. We must divide this with g at x, which is x plus 5 squared. So this is the same as saying x plus 5, x plus 5. So we FOIL x squared plus 5x, 5 to x plus 5x, 5 to 5 plus 25, which is the same as x squared plus 10x plus 25. So this is what we will put underneath here. And if we FOIL here, what do we get? We get 3x cubed. We get plus 4x squared. We get 15x squared. And we get 20x minus times x cubed, it's minus x cubed, minus 2x squared plus 1, all divided by x squared plus 10x plus 25. If we want to, we can leave this as x plus 5 squared if we want to. So we'll just add there. So we have 3x cubed. We have only one. Oh, that becomes 2x cubed because this one will cancel, will minus the 1. So 2x cubed. And how many squared we have? We have 4x squared, 15x squared, that's 19x squared, minus 2x squared, that is plus 17x squared. And we've got 1x, 20x, and we only have 1. So it's going to be plus 20x plus 1, all divided by x plus 5 squared. So that is the quotient rule, and that is how you would apply it. Sometimes it won't be easy like this. Sometimes they might say, as long as you know the rule, sometimes they might divide by 2x or 3x, and maybe here they put sec x. So as long as you know it. Sometimes they can combine it. Sometimes they can give us maybe x sine x divided by ex. So you see, it's for us to get the derivative of f at x, we need to apply the product rule. Then we can get the derivative of this without a lot of stress. maybe sometimes they can put 2x here. So for us to get the derivative of this, we will still need to use the product rule. Then we apply the formula, then we get the answer. So that's it on the product rule. Before we go to the derivatives of trigonometry, let me just add few more things. Sometimes we can be asked to find the derivative of log base ex. So if they ask us to find the derivative of this, we must remember this. This is equal to 1 over x. Finish. There's nothing to worry about. But what if we asked it to find the derivative of log? Now here it's not e, it's a number. Let's say it's 3 and there is x. So what is the derivative of this? On this case, you're still gonna divide. But what must you do with 3? 3 becomes ln 3 and x comes here. So if they say find the log x, we know that we have 10 here. So this would be 1 over x ln 10. So that would be the way we would apply if we given logs and we asked it to differentiate them. Sometimes we'll be given trig functions. So trigonometry functions, you just have to take what I say, remember it, or try to familiarize yourself with the formula sheet, because the formula sheet will have these things. So a formula sheet must tell you. If it doesn't tell you, you know it from today. A derivative of sine x. Sorry, there will be a video where I'll be proving these things. I just can't prove them on this introduction because it will make this video very long. So if we given sine x, the derivative of sine x is cos x. If we given cos x, the derivative of cos x is minus sine x. If we asked to find the derivative of tan x, the derivative of tan x is equal to sec squared x. If we asked to find the derivative of cot x, the derivative of cot x is minus cosec squared x. The derivative of let's say we asked to find the derivative of sec x, then the derivative of sec x will be sec x tan x. If we asked to find the derivative of cosec x, you might have guessed it. It's gonna be minus cosec x times cot x. That's it. Take this, remember it, use it wherever you go or wherever you are asked to find the derivative. Sometimes we will be given the inverses. It's, I don't know whether it's a good idea. Sometimes we'll be given sine minus an inverse, sine inverse of sine or arcsine x. For this one, we've got the formula which says 1 minus x squared. So you just apply this formula. This one also has a formula. I'm not gonna dwell much on these formulas. This is one of the other formula sheets that I happen to get. So you see arcsine has this formula, arccos has this formula, arctan has this formula, cot has this formula, arcsec has this formula, arccosec has this formula. So this formula sheet, I would say it's giving the student 100% on differentiation. For example, if they were writing this paper, let's say maybe the paper had 30 marks of differentiation, I really don't understand why would a student don't take all of those marks, because there is this formula sheet which tells the student how to differentiate. Like everything we spoke of is given to the student. Like, what else did we spoke about? Where is this formula sheet? Like, we spoke of this, we spoke of this, and this, and this, and that, 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 and that. We also spoke of what is this? This is the integral. This is the integration. I don't see this formula sheet. Oh, here is this formula sheet. So differentiation, like this is the quotient rule. The product rule that we spoke of is here. It's just that they choose to use U, V. So there is also a chain rule that we didn't speak about, and we still gonna do the chain rule just now. Let us now do the chain rule. Where does the chain rule apply? Chain rule applies where we have a function of a function, like this. So this is a function of a function. For example, this is the same as saying sine x squared. Here we cannot use the product rule, because if we say f at x is equal to sine, we're gonna say sine what? So product rule does not apply. Well, we were gonna say g at x is equal to x squared, but now that sign gives us a problem. So here we need to apply the chain rule, which some other textbook refer to it as a u substitution. So we need to substitute x squared with u. So if we let u equal to x squared, so here we will be left with sine u. So we want the dy over du of sine u, and this we must multiply it with the derivative of this, which is du over dx, which is x squared. So this will be the same as saying Sin u is the same as cos u times x squared. This would be 2x. But now remember u is equal to x squared. So this is the same as 2x cos x squared. So that's the derivative. We've applied the chain rule. Sometimes this can be challenging. Like they can also say, let's find the derivative of cos into x plus, let's say, tan x. They can put anything here. So again here, we need to remember that we let this be equal to u. So for us to get dy over dx, we need, let's let u equal to x plus tan x. So the formula says we need to find dy over du. So this makes this equal to cos u. So dy over du cos u times du over dx, which is x plus tan x. So the derivative of this is minus sine u, and the derivative of that is 1 plus, what is the derivative of tan x? Is sec squared x, sec squared x. So this is the same as 1 plus sec squared x into sine u. Remember u is x plus tan x. So this was supposed to be the introduction, but I had to go a little further for you to be able to grasp this chain rule. So see you on the other video. We will be advancing on the exercises of these rules that we've discussed for differentiation.